Hi, this is Adnan, and this is our second lesson in our series of IGCSE Cambridge Chemistry. The course code is 0620. So this is our second topic in chapter 1, which is diffusion 1.2. So let us talk about diffusion. What is diffusion? Let me try to relate it from some real life examples. We this is something that we experience almost daily. Like for example, if you enter a room where someone is wearing a perfume, and you can smell that fragrance across the room. So how is it possible that the person is sitting in one corner of the room and you are able to smell that fragrance in another corner? So that is because of the concept or the phenomena of diffusion. And another example will be that if if something is being prepared in a kitchen, and you can smell it in the entire house. So and that is also because the phenomena of, or the process of diffusion. So what is basically diffusion? Diffusion is the movement of particles from the area of a higher concentration towards the area of a lower concentration. So where the particles are higher in concentration, they will automatically spread out, and they will go towards the area where their concentration is minimum. So this is built in their nature, and they try to go away from each other. The particles, they try to move away from each other, and this is how we experience fragrances across the room, and we can smell what is being prepared in the kitchen. So this is basically what diffusion is. So in IGCSE Cambridge Chemistry, this topic is explained under two subtopics. Let me just paste the headings on the whiteboard. So the first one is describe and explain diffusion in terms of kinetic particle theory. So in order to explain the concept in terms of the particle theory, so we have already studied this in our previous topic, solids, liquids, and gases, that solids, and they have very low kinetic energy, and that is why the particles are tightly packed together. They are held together very tightly, and they cannot move. So one thing that you need to understand here, that the process of diffusion, this phenomena, can only be exhibited by those by a matter in a state where particles can move. And since in solids, particles, they do not move, so solids cannot undergo a diffusion, right? So diffusion does not occur in solids, since the particles cannot move from place to place. They only vibrate in fixed position. So diffusion can only occur in liquids and gases, since the particles in these states of matter are able to move, collide with each other, and they spread apart. So this is all we need to know under this topic. Describe and explain diffusion in terms of kinetic particle theory. So liquids and gases, they will exhibit, or they will undergo diffusion, and solids, they do not show this phenomena. Okay, so now we are moving towards the next topic, which is under the supplement or extended syllabus, and that is describe and explain the effect of relative molecular mass on the rate of diffusion of gases. Okay, so uh, the heavier the gas, the slower will be the rate of diffusion. So this is the uh, you know relationship here. And or we can say that molar mass or molecular mass is inversely proportional to the rate of diffusion. Rate of diffusion. So if the molecular mass is higher, so the rate of diffusion will be slower. And if the molecular mass is lower, the rate of diffusion will be higher, right? So relative molecular masses refer to the mass of one molecule calculated by the sum of the atomic masses of all the atoms in a molecule. For example, the relative atomic mass of ammonia is 17, because nitrogen has the mass of 17 and hydrogen has a mass of 1. So, sorry, nitrogen is 14. So we have one nitrogen and we have three hydrogens. So 14 plus 3, we get 17, right? So this is how we calculate the molar masses. So the larger the relative molecular mass, the slower the rate of diffusion. And this is because the larger the relative molecular mass of the gas particles, the heavier the particles, right? So the slower the and so the slower the particles move, and the slower the rate of diffusion. So heavy particles, they move slowly, and lighter particles, they can move fast from one place to another. So the smaller the relative molecular mass of the gas particles, the lighter the particles. So the particles will move faster and the rate of diffusion will increase. So this is what we need to understand here. Now we can develop our understanding further by solving a few questions from past papers. So I'm pasting this question from paper 4, extended. Okay, so question 3, this question is about the first 30 elements in the periodic table. Name the element which is the gas with the slowest rate of diffusion at room temperature. So a periodic table is given, it is printed on your question paper, so you don't have to memorize the entire periodic table. So you just need to understand how to read it. So if you look at periodic table, so it starts from hydrogen, which is element number 1, and element number 30, I believe, is zinc. But if you look at the gases that are included among the first 30 elements, they are hydrogen, helium, right? We have nitrogen, oxygen, and we have fluorine, we have neon, we have chlorine. So these are the gases under first 30 elements, right? So we should know that gases, like for example, nitrogen, oxygen, fluorine, chlorine, they all exist as diatomic molecules. So the heaviest gas is going to be chlorine gas, right? So Cl2. So the answer will be chlorine. So chlorine will have the heaviest gas, will have the slowest rate of diffusion at room temperature. Okay, so now we can take a look at another question. Let me paste this question on the whiteboard. Okay, so the names of the elements of period 2 of the periodic table are shown. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Answer the following questions about these elements. Each element may be used once, more than once, or not at all. Identify the element which has the highest rate of diffusion at room temperature. So now they're asking about the highest rate of diffusion. So we should look for the lightest gas out of all these elements, right? So okay, yeah, and it has to be a gas because solids, they do not show diffusion. So they can't diffuse because the particles are closely packed. We have discussed it earlier. So the gases are nitrogen, oxygen, fluorine, and neon. So we can see that the lightest gas will be neon because uh, nitrogen, oxygen, and fluorine, they exist as diatomic molecules. This is very important that you should understand, and that which gases are diatomic and which gases can exist in a monoatomic state. So the noble gases, these are the only gases that can exist as monatomic gases, right? So even though if like single fluorine atom will be lighter than neon, and hydrogen, oxygen will be even lighter than that, and nitrogen will be even lighter, but since they existed as diatomic molecules, all of them, they become heavier as compared to neon. So the highest rate of diffusion, the lightest gas, and that is neon. And identify which element. So you write neon, right? So this is the answer. So this is how, this is the type of questions that appear on the exam. So if you have any questions, leave them in a comment, and like, subscribe, and share. And if you are looking for one-to-one tutoring sessions with me, or group sessions, the link is given in the description. So I have a community on school.com, high school chemistry. You can select the desired package. It's a free community. You can join it for free. But for like weekly lessons, there's a premium package available as well. And if you need one-to-one lessons, so the Google form is given in the description. You can fill it, and I'll contact you. So this will be all from my side for today, and I'll see you in the next one. Take care. Goodbye.